Hello and welcome to this video about flat mirrors. In this video we're going to look at what reflection is, different kinds of reflection. We'll look at the angle of incidence and the angle of reflection, where those are, flat mirror diagrams and how to draw them, and what we are talking about when we talk about virtual images. So first, let's take a look at what reflection is. Reflection is just the change in the direction of light or any electromagnetic wave at the surface of some substance. We have two different kinds of reflection, and from the frame before, you saw the little puppy looking at his reflection in a mirror. The kind of reflection that he was seeing was specular reflection. Very smooth surfaces have specular reflection. This occurs when the incoming light traveling in parallel rays here will be reflected in the same direction, and they will be reflected in parallel rays as well. Diffuse reflection would happen if that puppy were trying to look at himself in a brick wall. That would be a rough surface, and we do not have the reflection. The reflected rays are not traveling parallel to each other. They are traveling in many different directions and at different angles, and therefore you do not see an image. So let's take a look at a reflection of an object. Here we have a nail or a tack. We have incoming light, and it hits the surface, this reflecting surface right here, and it will reflect. Here we have the reflecting light ray. We also define the normal as the line that can be drawn perpendicular to the reflecting surface. Now, the law of reflection states that the angle of incidence is equal to the angle of reflection. And here we have represented that here. We have the angle of incidence would be this angle. It is the angle between the incoming light ray and the normal. The angle of reflection would be theta prime. That would be this angle between the normal and the reflecting light ray. Those are always equal when light is reflected. The simplest mirror or reflecting surface is a flat mirror. So we're going to take a look at flat mirrors and how to draw a ray diagram. If we have some object like this tack or this nail, and it's placed at some distance in front of this flat mirror, and light is bounced off of this, the light rays spread out from the pencil and then they reflect from the mirror's surface. To some observer that's looking in the mirror, the rays appear to come from a location on the other side of the mirror. So as a convention, the object's image is said to be at this location behind the mirror. We call this kind of image a virtual image because the rays appear to come together at a point behind the mirror, behind the reflecting surface, but they never do. The rays don't actually hit it. So it's called a virtual image, and all flat mirrors always form virtual images. Here is a ray diagram that has been drawn. If you were to construct your own ray diagram of an object, you would choose, we could choose the tip of this object here, and draw our first ray actually at a 90-degree angle to the surface of the reflecting surface. That would be the first ray that we would draw. Because this ray makes an angle of 0 degrees with the normal to the mirror, it is simply going to reflect back on itself. And here that is ray 1 going this way, and then it's reflecting back on itself this way. The second ray that we would draw would be from the same point on the object, and it would be a ray that goes from that object to the mirror, but that is not at a 0-degree angle to the normal. It would be something other than a 0-degree angle. Then we would draw the reflected ray of that. This would be the reflected ray, and we would call that ray 2. It's the reflected ray from this incident ray right here. This is ray 2, and you can calculate that because you know that the angle of incidence equals the angle of reflection, so you can find exactly what that reflected ray, what angle that reflected ray would be at. The last step is to trace both of those reflected rays back to the point from which they appear to have originated behind the mirror. And we draw these in dotted lines. So we would put a ruler here, trace this back behind the mirror. We would put a ruler here and trace this line back, this ray back to a point behind the mirror, and where they intersect would correspond to that same point on the object. And again, we keep these dotted lines. This image is virtual because the rays don't actually form it. They just appear to form the image in this location behind the mirror. So a few conventions that we will use when we make ray diagrams. P represents the distance in front of the mirror that from which the object is placed. Q would represent the distance from that mirror to that virtual image behind the mirror. P and Q are always equal for a flat mirror, meaning that the image appears to be the same distance on the other side of the mirror as it is on the side where the actual image exists. Another convention is the height, h, of our object is what we can term the height of the object. H prime is what we call the height of the image. And for a flat mirror, those are equal. In other words, we don't have our object magnified or diminished. The image of the object is not magnified or diminished. Looking for advanced ideas? What are some interesting applications for flat mirrors? A lot of applications for mirrors in general, but look at some for flat mirrors and some ways that they're used. And any other ideas you have about anything you'd like to look at. I look forward to seeing what you come up with, and we'll see you in class.